Hello, Algebra 2. Welcome to the section 7.4, where we are going to continue our journey with logarithms and looking at how we can expand and condense logarithms using a couple properties. And the properties are related to exponents because logarithms, remember, are just solving for missing exponents. So it's important to kind of keep that in mind, that when you solve a logarithm, you are finding a missing exponent that connects and completes your equation. So our goal by the end of today is to use the three properties of logarithms and then also learn a little trick. If you don't have the ability to change the base of your logarithm, then you can still solve any logarithm base using a little trick called the change of base theorem. But here's our three properties. So first is the product property. So the product property says that if you have two logs that have the same base that are being added, you can condense that down and write it as one single log with the two values being multiplied. So log of x plus log of y could be rewritten as log of x times y. Well, this is because when you multiply two powers with the same base, you're adding their exponents. So here our exponents are being added. Well, that's the same as the result of multiplying two powers. So it relates back to that exponent rule where you're adding your exponents when two powers are being multiplied. Similarly, the quotient property then says that if you have log of x minus log of y, that can be rewritten as the log of x divided by y. And same idea, when you're dividing two powers with the same base, you're subtracting their exponents. So here we have our two exponents being subtracted, and we can rewrite that then as a division problem. And lastly is the power property that says if you have a log of x raised to the a power, that a can be at any time dropped down in front of the log. So this would be like when you have a power to a power situation with exponents, you're going to multiply your two exponents together. So we're taking the exponent of a times that exponent of log x. So we're going to practice first condensing logs. So looking at having multiple logs and can we simplify it down, and then we're going to look at expanding logs, where we're going to try to write multiple logs for the situation given. So let's take a look at example 1. So example 1, we have two logs. We have log 3x minus 2 log 3 7. So first, this 2 out in front, since that's written as a coefficient, I can rewrite that as an exponent using that third property. So then this would be the log base 3 of x minus the log base 3 of 7 squared. So I can use that power property. Now 7 squared is 49, so now I have 49 right there. And I can now apply the quotient rule. Since I have a minus here, I'm going to go log base 3 of x divided by 49. So there would be my one single log to represent that situation. So I can take 7 squared, which is 49, and since it's a minus, I'm going to write my two values as a quotient. On to part B, we can see that we have both a log base of 8, so we can go log base of 8, and then since it's plus, we have a 48 times 4/3, and how we can simplify that. And 48 times 4/3 is 64, so we'd have log base 8 of 64, which, getting our log brains going, we got to think, what is this asking? Well, this is asking 8 to some power is equal to 64, and that simplifies nicely down to 2. So our final answer for B is just going to simplify all the way down to 2. So if we can, we get it simple, 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 as much down as we can. So you can pause the video right here, and I will show you the answers to the now try, but you can try those and then check your answers here in just a second. Next, we're looking at expanding logarithms. So we're going to use our properties to write multiple logs. So here, both of these just have one single log. We're going to expand these out using our power properties, our log properties, excuse me. So here we have a log base 5, and then we have a 125 up in the numerator there. And then the denominator, we have an x and a y. So we are going to be dividing by both x and y. So using that quotient property, we'll subtract both of those logs. So we'd have the log of 125 minus log 5 of x minus log, forgot the 5 there, minus log 5 of y. Because both the x and the y are being divided, so we would subtract both those logs. Then again, if we can see a log that can be simplified, like this log 5, 125, that's 3. So we'd simplify it. So that's going to be 3 log 5x and minus log 5y. So there's going to be our expanded logarithm. And again, if we can see something that's clicking, we're going to want to simplify that. And heading to our second problem, we're going to have all those are being multiplied. So we're going to have 3 logs being added together. I'm going to start over here because we're going to have multiple logs. We're going to have log x squared plus log y squared plus log z to the negative 1. And then each of these, if they have an exponent, we can take that exponent, write it as a coefficient. So this 2 comes down, this 2 comes down, and this this negative 1 comes down. So ultimately, it ends up being 2 log x plus 2 log y minus 1 log z. And I don't need to put that 1 there, but I just did for some reason. But there would be our expanded log. So that's as much as we could get. I guess here you have a 2. You could factor out a 2. So you could put the 2 out in front and then like kind of have it like the reverse of the distributive property, but that is a-okay to leave it just like that. So I now have the I try or the now tries ready to go. So if you pause the video here, you can try those, and then I'll show you the answer here in just a second. The next is the change of base formula. So this is useful if you have a calculator that does not allow you to change the base. You can find a logarithm in any base, and most often it's using the common log, which is base 10, because that's what most calculators are going to have. But the change of base formula says that if you have a log in some base, we'll call it m, to n, you can take the common log of n divided by the common log of m. So heading down to here, we have a log base 9, 111. This is going to be log of 111 divided by the log of 9. In our second problem there, we'd have the log of 36 divided by the log of 216. So we should be able to use the common log to find any log that we want by using this change of base. So I'm going to head to my calculator. We'll solve both of those, and then I'll have the answer to the now try after that. So let's head to the calculator. So in our calculator, we all have the log button there. Most scientific calculators will have at least the common log. So that first problem, we had the log of 111. Make sure that we close off the parentheses, divided by the log of 9. So this should find out what power 9 or what exponent 9 needs to be raised to in order to get to 111. So we should get 2.14. If you're wanting to check that, you could hit 9 and then hit your exponent button, raise it to that exponent, and that gets us back to 111. Next one we had was log of 36 divided by the log of 216. gets us that exponent. So that means that if you take 216 and you raise it to that exponent, that gets you to 36. Pretty dang close there. So there's your change of base theorem. So anytime you can use the common logs to calculate any log that you wish. So now we're ready for the now tries. You can pause the video here, and if you're looking to try those out, I'll show the answer here in a second. Lastly, we have a log formula that's used in calculating wind speed for tornadoes. So a tornado's wind speed can be calculated depending on how long it is touching the ground. So as it travels on the ground, its wind speed will pick up faster and faster. So here our formula is that the speed equals 93 log d distance plus 65. So we want to find out what's the difference in wind speed between a tornado that traveled 16 miles and one that traveled 8 miles. So we will calculate each of these individually. So first one, S is going to equal 93 log D for that first tornado is 16 miles, and then we'll add that 65 on. Secondly, we'll do the speed of the second tornado, which is S equals 93 log, this time 8-mile tornado, plus 65. So it's important to notice that the plus 65 is not in parentheses with the D distance. So when you're typing this in, you're going to want to make sure you close off your parentheses on 16 and then close off your parentheses on 8 to not include that plus 65 in the parentheses of calculating your log. So you're just calculating the log of 8, not 8 and 65 added together. So heading to our calculator then, we'll calculate both of these and then see the difference in the wind speeds. So we'll hit 93 using our common log button. First wind speed distance was 16 and then plus 65. So that tornado had a speed of 177 miles per hour, roughly. Second tornado was on the ground for 8 miles, so we'll go 93 log 8, close off our parentheses, plus 65. That had a speed of 148, and then find the difference between those. We'll take our first tornado speed minus our second tornado speed, subtract those, and we get an answer of about 28 miles per hour. So the first and second tornado were about a 28 mile per hour difference in their wind speeds. So with just one application of using logs that we can see. So that does it for section 7.4. So 7.4's goal is to get you more comfortable with logs and thinking about them as exponents and practicing the condensing of logs, expanding of logs, just to further your knowledge of logs. So that will do it for section 7.4. You're ready for the assignment. You can go ahead and good luck, and we'll see you next time.